Good afternoon, friends, and welcome again to another session of the mathematics class 12. As you know that we are continuing with the functions, inverse trigonometric functions. So this is the part 2 of the inverse trigonometric functions, and already part 1 has been uploaded. So part 1 is already uploaded. So my request to you, all of you, is please go through the part 1 before you see the part 2. So please refer to the part 1 of the inverse trigonometry functions so that you can understand the continuity of this chapter. Okay, so as you all know, this is Parijat sir classes. This is Parijat sir classes going on, and we are doing the mathematics class 12, maths class 12. This is the inverse trigonometry functions going on. So please keep following, as this is a complete discussion of the inverse trigonometry functions, and I can guarantee you that nothing outside this is going to come in your board exams. So for the board exams, ISC, CBSE and any other entrance exams, please note that these are very important things which we are going to discuss. So please keep following Parijat sir classes. So let's get started with the inverse trigonometric functions. And before this, please go through the first part of the inverse. So let's get started with the part 2. So as you can see here, sine inverse x is equal to x. These are the important formulas which I am discussing here, and you also have to note these formulas so that you can see understand the chapter very well. Sine inverse x equal to x for x belongs to -1 to 1. The value of x should be from -1 to 1. Cos inverse x will be cos x, tan inverse x will be tan x, cosec inverse x will be cosec inverse cosec x will be x, sec inverse sec x will be x, cot inverse cot x will be x. And these are the ranges which you have to take care of. X should belong between this range. For the cos, it is sine and cos is the same. So tan will be infinity, the real numbers, any real numbers, tan. For cosec, it is -infinity to -1, and then again 1 to infinity. 0 is not counted. So for sec, it is -infinity to -1, same as that of the sine. Sine and cos are same, so cosec and sec will also be same. And for tan and cot, it is also the same. Tan and cot are same. Sec and cosec, sine, you see that sine, cos are same, sec, cosec are same, and tan and cot are same. So please keep a note of this, and let's move on to the next part. So the next part says that evaluate sine of sine inverse 5/13. So sine inverse sine of 5/13, as we already have done sine inverse sine of sine inverse x, as you can already see from here, sine of sine inverse x is x. So using this concept, we are getting here sine of sine inverse 5/13 is 5/13. Similarly, sine of cos inverse 4/5. Now first of all, we know sine of sine inverse x is x, but this is cos inverse, so we have to convert the cos inverse to the sine inverse. So see, how to convert cos inverse 4/5, let it be theta. So cos theta is 4 by 5, and we know cos theta is base by hypotenuse. That means I can tell 4 is my base, 5 is my hypotenuse, so I can find out the perpendicular. So what will be sine theta? Sine theta will be perpendicular by the hypotenuse. So what is theta? Theta is sine inverse 3 by 5. So theta was cos inverse 3 by 5. So instead of this, I can write sine inverse 3 by 5. So cos inverse 4 by 5 can also be written as sine inverse 3 by 5. Now it is sine of sine inverse x. Now we are using the formula sine of sine inverse x should be x, and using that we are getting 3 by 5. Clear? Similarly, if I use sine of tan inverse 15 by 8. So first, same way, let tan inverse 15 by 8 equal to theta. That means tan theta is 15 by 8, and we know tan theta is perpendicular by the base. So I can tell that my perpendicular is 15, my base is 8, so hypotenuse I can find as 17. So sine theta will be 15 by 17. So theta will be sine inverse 15 by 17. So instead of tan inverse 15 by 8, I can write sine inverse 15 by 17. So using this concept again, we are using answer is 15 by 17. Clear? Let's move on to the next one. Evaluate cos of cot inverse 15 by 8. Same way, let cot inverse 15 by 8 equal to theta. So cot theta is 15 by 8. Cot theta is what? Base by the perpendicular, opposite of tan theta. That means my base is 15, my perpendicular is 8, so my hypotenuse will be 17. So I need cos. So cos will be base by hypotenuse. So theta will be cos inverse base by hypotenuse. So instead of cot inverse 15 by 8, I can write cos inverse 15 by 17. Okay, and now using this concept, cos of cos inverse x is x. So we are getting the answer as 15 by 17. Next, cos of sec inverse 5 by 3. So again same way, let sec inverse 5 by 3 be theta. So sec theta is 5 by 3. Sec theta is opposite of cos theta, which is 3 by 5. So this 3 is my base, 5 is my hypotenuse, as you can see. So I can calculate the perpendicular, which is 4. So from here we get cos theta equal to 3 by 5. So theta will be cos inverse 3 by 5. So putting here, we get the answer as 3 by 5, because cos of cos inverse x equal to x. Similarly, so cosec inverse 13 by 12, here we have to get cos inverse. So same way, let cosec inverse 13 by 12 be theta. So cosec theta is 13 by 12, that is, this is my hypotenuse, this is my perpendicular, opposite of sine theta. So I can calculate the base as 5. So cos theta will be base by hypotenuse, so theta will be cos inverse 5 by 13. So putting here, so cosec inverse 13 by 12 can be written as cos inverse 5 by 13, and we get the answer as 5 by 13. Clear? Next is again some important formulas which you have to note it. I would suggest please note all these formulas, because these are very, very important formulas for you. These are very, very important. Let me write few more of them so that it is easy for you. What? 1 plus cos theta is equal to 2 cosec square, 2 cos square, 1 minute, 2 cos square theta, 1 minus cos theta will be 2 sine square theta. Then we can write 1 plus sine theta. We can write it as cos theta by 2 plus sine theta by 2 whole square, and 1 minus sine theta. We can write it as cos theta by 2 minus sine theta by 2 whole square. We can write this. These are also very, very important formulas. Okay, so let's get started. If we need more, then we can again come back to this page. So please keep a note of these formulas, because these are the things which are going to guide you. Very, very important formulas. Sine inverse of x is written as cos inverse root over 1 minus x square. Tan inverse of x by tan inverse sine inverse x can be written as this. Sine inverse x can be written as this. Sine inverse x can be written as this, and sine inverse x can be written as this, and sine inverse x can be written as this. So many ways sine inverse x can be written. Similarly, please watch here, sine inverse minus x and cosec inverse minus x. Please watch here. Sine inverse minus x, cosec, next is tan inverse minus x, and cosec inverse minus x. They have the same formula. They have the same formula. And similarly, if I see cos inverse minus x, sec inverse minus x, and cot inverse minus x, they have the same formula. So please keep a note of this. Okay, so and these here also you have to take a note of this. Sine inverse minus x is cosec inverse x. Cos inverse 1 by x equal to sec inverse x. Tan inverse 1 by x is cot inverse x for x greater than 0, and minus pi plus cot inverse x for x less than 0. Similarly, this is a very, very important formula. Please take a note of this. Very important. These are very important formulas. Sine inverse x plus cos inverse x is pi by 2. Tan inverse x and cot inverse x is pi by 2. Sec inverse x and cosec inverse x is also pi by 2. Clear? These are very, very important formula. Similarly, this is also a very, very important formula. Please note it. Tan inverse x plus tan inverse y. Please note the formula. Very important formula. Similarly, tan inverse x plus tan inverse minus tan inverse y. These are the important formulas you have to note. These are very, very important formulas. You have to note it. So first, my request is please keep a note of these formulas before we proceed to the next part of the chapter. Okay, so let's go ahead. Similarly, see, here are again some important formulas, some very, very important. Sine inverse x plus or minus sine inverse y. Please watch here. If it is plus, then here is a plus. If it is minus, here is a minus. Similarly, cos inverse x plus cos inverse y, or cos inverse x minus cos inverse y. Similarly, 2 sine inverse x. Please watch the formulas of 2 sine inverse x. Sine inverse 2x into 1 minus x root over 1 minus x square. 2 cos inverse x is this formula. Cos inverse 2x square minus 1. 2 tan inverse x has 3 formulas. 3 formulas. These are very, very important. Similarly, 3 sine inverse x. 3 cos inverse x and 3 tan inverse x. So friends, you have to note these formulas very, very carefully so that you have to memorize this if possible. Write it many times, then only you will be able to understand what we are discussing. Otherwise it will be difficult for you to solve the sums. Next, let us see the applications of this. So first is evaluate cot tan inverse A plus cot inverse A. So first of all, see, tan inverse x plus cot inverse x is pi by 2, as we have already done here. Tan inverse x plus cot inverse x is pi by 2 here. Tan inverse x plus cot inverse x is pi by 2. Okay, so using this, so it becomes cot pi by 2, which is 0. Similarly, you have to prove that this plus this equal to this. So using the formula tan inverse x plus tan inverse y, this is our formula, tan inverse x plus y by x minus. So this is our formula. This is our formula. So now let us apply this. So tan inverse 2 by 11 plus tan inverse 7 by 12. This is my x and this is my y. So using it, x plus y by 1 minus xy. This is 1 minus xy we are doing, and we are getting, solving it, we are getting this, which is tan inverse of half, which is the proof. Similarly, let's see the next. Sine inverse 12 by 13 plus cos inverse 4 by 5 plus tan inverse 63 by 16. We have to prove that it is coming pi. So let us use the formulas one by one. Please watch here. Sine inverse x can be written as tan inverse x by root over 1 minus x square. So using this, we are converting. So sine inverse x can be written as tan inverse x by root over 1 minus x square. Similarly, cos inverse x can be written as tan inverse root over 1 minus x square by x. So here cos inverse x can be written as tan inverse root over 1 minus x square by x plus tan inverse 63 by 16. So solving this, we are getting this, and solving this, we are getting this. Now this is the formula of tan inverse x plus tan inverse y. This is the formula of tan inverse x plus tan inverse y, which is tan inverse x plus y by 1 minus xy. So using tan inverse x plus y by 1 minus xy, and solving it, we are getting this plus this. Now tan inverse minus 63 by tan inverse minus x. Please watch here. We gave a formula already. Here is the formula. See, tan inverse minus x. So here is the tan inverse minus x is coming. This is in the case if tan inverse x. So please watch here one thing. Tan inverse minus x. Now this is more than, now your x is more than 0. So tan inverse minus x is actually pi minus tan inverse x. So using this, we are getting this, and this cuts. So this is our proof. Clear? This is our proof. Please note this formula, tan inverse minus x. Now if that x is greater than 0, if that x is greater than 0, so this is our formula. Clear? Next, let's move on to the next part. So the sum says sine inverse, prove that sine inverse 8 by 17 plus sine inverse 3 by 5 equal to this, equal to this. So first of all, let us use the formula sine inverse x plus sine inverse y. Let us use the formula sine inverse x plus sine inverse y. What is the formula? This is the formula. Sine inverse x root over 1 minus y square plus y root over 1 minus x. So here we are using sine inverse x plus into root over 1 minus y square. This is my y, this is my x, and this is my y. So here we are using the formula. Similarly, y into root over 1 minus x square. So solving it, we are getting this. So first part we got, but now from here we have to reach here. So now same way, sine inverse x can be written as tan inverse x. This is how the formula comes. Sine inverse x is tan inverse x by root over 1 minus x square. So using it, this is my x, so x square, and we solving it, we are getting this as the answer. Clear? Next sum, let's see. Prove that cos inverse this plus cos inverse this equal to sine inverse this. Okay, so first what we will do is that we will convert the cos inverse into the sine inverse. So this is our formula. Cos inverse x is sine inverse root over 1 minus x square. So this we converted to the sine inverse, and this is sine inverse 3 by 5. Now we are using this formula, sine inverse x plus sine inverse y. We are using sine inverse x plus sine inverse y equal to sine inverse x root over 1 minus y square plus y root over 1 minus x square. So using this, this is my x, this is my y. So solving it, we are getting sine inverse 56 by 65. So friends, let's see the next sum. Prove that sine inverse 3 by 5 minus sine inverse 8 by 17 equal to this. So we are using this formula, sine inverse x minus sine inverse y. So this is my x and this is my y, and using this formula we are getting this as sine inverse 13 by 85, but I have to convert to cos. Now sine inverse x is cos inverse root over 1 minus x square. So here we are using sine inverse x is cos inverse root over 1 minus x square. So we are getting this calculations. So please pause the video and try to use your formulas and try to calculate on your own. Then only you will be able to understand this. So my request is, please pause the video, apply the formulas which you can, or continue to do with me by your own applications. Then only you will be able to understand this. Clear? Next, let's see. Evaluate sine 2 sine inverse 0.8. Okay, so we have to simplify. We have to simplify it. How much it comes? Now 2 sine inverse 0.8. What is 2 sine inverse x? Is sine inverse 2x root over 1 minus x square. So this is my x. So sine inverse 2x root over 1 minus x square. Solving it, we get this. Now sine of sine inverse x, sine of sine inverse x, as you already know, is x. So this is the answer. sine of 3 sine, so 3 sine inverse x formula is this. 3 sine inverse x, this is a formula, sine inverse 3x minus 4x cube. So this is my x. So sine inverse 3x minus 4x cube, and on solving this we are getting this. Now sine of sine inverse x we already know is x. So this is our answer. Clear? Let's see the next sum. Prove that tan inverse x plus tan inverse of this equal to this. Now we know 2 tan inverse x equal to tan inverse 2x by 1 minus x. That means this is actually 2 tan inverse x. This is actually 2 tan inverse x. This 2 tan inverse x. Okay. So now 1 tan inverse x and 2 tan inverse x is 3 tan inverse x, and 3 tan inverse x, already we used this formula. 3 tan inverse x, the formula is this. 3 tan inverse x is this. So we have proved it. Okay, 3 tan, please note that this is the formula. 3 tan inverse x is actually this. Evaluate tan of 2 tan inverse 1 by 5. So 2 tan inverse x is tan inverse 2x by 1 minus x square. So here we are using the formula. 2 tan inverse x is tan inverse 2x by 1 minus x square. Solving this, we are getting this. And now we know that tan of tan inverse x is actually x. Using this, we are getting 5 by 12. Similarly, see tan half, now this and this. So please note that sine inverse 2x by 1 plus x square is the formula of 2 tan inverse x. Similarly, cos inverse 1 minus x square by 1 plus x square, the formula is 2 tan inverse x. So using this is 2 tan inverse x, 2 tan inverse x, take 2 common, it cuts out. So this, now tan inverse x plus tan inverse y, this is the formula. So tan and tan inverse cuts, and that is the answer. Tan and tan inverse will cut. We are using the concept tan of tan inverse x is equal to x. So whenever tan and tan inverse come, they cut. This is the answer. Next, prove that tan inverse root x plus 2 tan in equal to 2 tan inverse of this. So please watch here. 2 tan inverse x is cos inverse 1 minus x square by 1 plus x square. This is our formula. Now if I take it as root x, then I can take it as root x square and root x square. So this is what I have written here. This is how you will write here. Okay. This x is written as root x whole square. Now this part is actually 2 tan inverse root x. This part, as you can see from here, 2 tan inverse root x will be this. So this part is 2 tan inverse root x, 2 cuts this. So that is our answer. Now let us use this. Root over 1 plus cos x is this formula, and root over 1 minus cos x is this formula. Using it, we are getting this. Okay, so let's move from here. So if I take root 2 common, root 2 is cut off. So cos x by 2 plus sin x by 2 by cos x by 2 plus sin x by 2. Now what we are dividing? We are dividing the up by cos x by 2, as you can see here, and we are dividing the down by cos x by 2. So this becomes 1, this becomes tan x by 2, this becomes 1, this becomes tan x by 2. Now in place of 1 I can write tan pi by 4, and this I can write it as 1 into, so this 1 can be written as tan pi by 4. Now this is the formula of, so tan x plus y, the formula is tan x plus tan y 1 minus tan x tan y. Okay, so using, so this is the formula of tan a plus b's formula. So this is pi by 4 plus x by 2, and now tan inverse of tan will cut, and that is the answer. Whenever tan and tan inverse are there, they will cut. So now using this next sum, let us see what is there. Okay, so prove that cot inverse of this plus this by this minus this equal to x by 2. So as I already showed you, 1 plus sine x is the formula is this cos x by 2 plus sine x by 2 whole square. 1 minus sine x, this is the formula cos x by 2 minus sine x by 2 whole square. So we are using this, the square and root cuts, so then this will cut. So 2 cos x by 2 by 2 sin x by 2, 2 cuts, this is cot x by 2, and cot inverse of cot is x. Cot inverse of cot x is x. Clear? This is how we proved it. Next, prove that cot inverse this, we have to prove it this. So 1 plus sin x, already we know the formula. 1 minus sin x, we know the formula. So applying this square and square root cuts, so this cos cuts and sine cuts, so we are getting 2 sin x by 2, and 2 will cut. So it is coming tan x by 2, but outside is a cos, so I have to bring it cot here. So cot pi by 2 minus x by 2, cot pi by 2 minus x by 2 is tan x by 2. Please note that cot pi by 2 minus x by 2 is actually tan x by 2. Using this we get, so cot and cot inverse cut, so this is the answer. Next, prove that tan inverse of this is coming this. So let's first rationalize the denominator. So what we have done is that we are multiplying the denominator, rationalizing the denominator. As you can see, we are multiplying with the opposite sign here, plus. So we are multiplying with the opposite sign, up and down. So up is the square and down is a plus b into a minus b, which is a square minus b square. So applying a plus b whole square, so we are getting this, and now a square minus b square, so root and square cuts, this and this cuts, so from here minus 1 and this will cut, so we are getting 2 plus 2 root over this by 2x square, 2 common, so we are getting this. Now please watch one thing, that is here, from here we have to start the sum by taking some variables. Let x square equal to sine theta, let x square equal to sine theta, so theta will be sine inverse x square, we have to use it later. If x square is sine theta, it will become tan inverse 1 plus root over 1 minus sine square theta by sine theta. 1 minus sine square theta is cos square theta, which is cos theta. 1 plus cos theta is what? 2 cos square theta by 2. Please keep a note of it. 1 plus cos theta, I've already given this, 2 cos square theta by 2, and sine theta is actually 2 sine theta by 2 cos theta by 2. So using this concept, we are putting here 1 plus cos theta is this, and sin theta is 2 cuts, cos theta cuts becomes this. So it becomes cot theta, and cot theta is tan 90 minus theta. Tan cuts, so we get pi by 2 minus theta by 2. Now we have to replace the theta. So what is theta? What is theta? Theta is sine inverse x square. So here instead of theta, replace, this is theta. Okay, but sine inverse x square, please note here, sine inverse x square, how to write it? Pi by 2 minus cos inverse x square. Why? Because sine inverse x plus cos inverse x is pi by 2. So sine inverse x will be pi by 2 minus cos inverse x. So sine inverse x square will be pi by 2 minus cos inverse x square. So this is pi by 2 minus pi by 4 plus half cos inverse x square. So see, pi by 2 minus pi by 4 plus half cos inverse x square. So pi by 2 minus pi by 4 is pi by 4 plus half cos inverse x square, and that is our proof. Next question. Simplify this. Sine inverse 5 by 13 cos x plus 12 by 13 sin x. So let us take 5 by 13 as sine theta. So here I can write, that means this is my perpendicular, and this is my hypotenuse. So I can find the base. So you can see here, so cos theta will be 12 by 13. So now tan theta will be what? Sin theta by cos theta, which is 5 by 12. So theta will be tan inverse 5 by 12. So now let us apply. So sine inverse, instead of 5 by 13 I will write sin theta, because I have taken 5 by 13 as sin theta, and instead of 12 by 13 I am writing cos theta. So this is the formula of sine. Please note here, sine a plus b equal to sine a cos b plus cos a sin b. So this is sine a cos b plus cos a sin b. So we are adding sine a plus b, and sine inverse and sine cut. So it is theta plus x, and instead of theta we are replacing it. So this is our answer, simplification. This is our simplification. Clear? Next, let us see sine inverse. This we have to simplify. So see how we are writing the root 2. 1 by root 2, and here 1 by root 2, and instead of 1 by root 2 I can write cos pi by 4, because cos pi by 4 is 1 by root 2, and sin pi by 4 is also 1 by root 2. Pi by 4 is how much actually? Pi by 4 is 45 degree. So cos 45 and sin 45 are 1 by root 2. Now this formula is this, sin a cos b plus cos a sin b. It is the formula of sin a plus b. So see, sin a cos b plus cos a sin b is the formula of sin a plus b. Now sine inverse and sine cuts. So this is our answer. Let's see, friends, the next sum. Sec square tan inverse 2 plus cosec square cot inverse 3 we have to prove as 15. So tan inverse 2. So let us write tan inverse 2. So I can take tan inverse 2 as theta. So theta will be what? Tan theta will be what? 2 by 1. This is my perpendicular, this is my base, so my hypotenuse will be root 5. So sec theta will be hypotenuse sec theta will be what? Hypotenuse by base. So theta will be what? Sec inverse root 5. Similarly, cot inverse 3 I have taken as alpha. So cot alpha is 3 by 1. Cot alpha is what? Base by perpendicular. This is my base, this is my perpendicular. So see, base and perpendicular, so hypotenuse I can find. So cosec alpha will be what? It is hypotenuse by the perpendicular, so root 10. So alpha will be what? Cosec inverse root 10. That means instead of cot inverse 3, I can write alpha, and alpha is this. So see, so instead of cot inverse 3, I write cosec inverse root 10. Instead of tan inverse 2, I can write sec inverse root 5. Now sec and sec inverse cuts, so root 5 square. Cosec inverse cuts, it is root 10 square, which is coming 15. So we have proved it. 15. So we have proved it. Next, so see, it is cos of tan inverse sine cot inverse is this. We have to prove this is this. Okay. First of all, cot inverse x can be written as sine inverse of this. Cot inverse x. Cot inverse x. So see here, let cot inverse x equal to theta. So x equal to cot theta. So sine theta will be what? Cot theta means what? Base by perpendicular. So my base is x, perpendicular is 1. So hypotenuse we can find. So sine theta will be what? Perpendicular by the hypotenuse. So theta is this. That means instead of cot inverse x, I can write this. So sine and sine inverse will cut. It becomes this. So now let this be again tan alpha. Let this be equal to alpha. So tan alpha is this. That means this is my perpendicular, this is my base. So hypotenuse will come root over x square plus 2. So cos inverse of, so cos alpha will be what? Base by hypotenuse. So alpha will be what? Cos inverse this. So here we have written. So cos and cos inverse will cut. This is my answer. Okay. From here alpha we can write it what? X square plus 1 by x square plus 2. This is the alpha, and we have, instead of alpha, we have put it here. We get the answer. Let us see the next sum. Simplify tan inverse a plus bx by b minus ax. So see what we have to do here. I am making here dividing by b. So this becomes a by b plus x, 1 minus a by b x. Now we know tan inverse x plus y by 1 minus xy. What is the formula? Tan inverse x. So we are using here tan inverse a by b. This is my x and this is looking my y. 1 minus this. So see, we are using tan inverse this plus tan inverse this, and that is the answer. Simplify this. So let us do one thing. Let us divide it by b cosecs, dividing by b cosecs. So see, dividing up and down by b cosecs. So this becomes a by b minus, this becomes tan x, this becomes 1 plus a by b tan x. So it is looking like the same sum above. So the formula of this is tan inverse a by b minus tan inverse of tan x. Tan inverse of tan x is x. So this is my answer. Next, tan inverse 3a square x minus x cube by a cube minus 3ax square. So let us put x equal to a tan theta. Why? Please note here that our target will always be to go to a particular formula so that we can use it. Our target will be to always go towards a particular formula. So if I put x equal to a tan theta, so this will become what? 3a cube tan theta minus a cube tan cube theta. This will become a cube minus 3a cube tan theta. So let us take a cube common, which will cut out. So this is the formula of tan 3 theta. So tan inverse and tan cuts 3 theta. So we have theta will be what? Tan inverse x by a. So that is my answer. Now let's see the next sum. Prove that tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is pi by 4. Okay, so let us take it into a group. This is these two into one group and these two into another group. So this is the formula of tan inverse a plus tan inverse b will be tan inverse a plus b by 1 minus ab. Using this we are getting this, and using this we are getting this. Again it is tan inverse a plus tan inverse b's formula. So again tan inverse, this is my tan inverse a plus b by 1 minus ab. Solving it we are getting 1, tan inverse 1 is pi by 4. That is my answer. Please note, our target will be to do in such a way so that we are always using some help of any formula. Clear? Next sum. Prove that sine inverse 4 by 5 plus sine inverse 5 by 13 plus sine inverse 16 by 65 is coming pi by 2. So sine inverse a plus sine inverse b, we have got the formula. Sine inverse a into root over 1 minus b square plus b into root over 1 minus a square. So using this, this is my a and this is my b. So sine inverse a into root over 1 minus b square plus b into root over 1 minus a square. Solving it we get sine inverse 63 by 65 plus sine inverse 16 by 65. Now watch one thing. Sine inverse x can be written as cos inverse root over 1 minus x square. So solving it we get cos inverse 16 by 65. Now see, the angles are same. So sine inverse x plus cos inverse x, our formula is sine inverse x plus cos inverse x formula is pi by 2. So using this we getting pi by 2. That is the answer. Similarly, let us prove this. So see, sine inverse x we are using this formula, cos inverse 1 root over 1 minus x square here we are using, and this is cos inverse 12 by 13. So we get this as cos inverse 4 by 5 plus cos inverse 12 by 13, and now we are using this formula. Cos inverse a plus cos inverse b will be cos inverse ab by ab minus root over 1 minus a square into root over 1 minus b square. So this is my a, this is my b. Solving it we are getting cos inverse 33 by 65, but I need sine inverse. So sine inverse will be root over 1 minus this x square. So we are getting solving this. Cos inverse x sine inverse root over 1 minus x square. We are using this formula. Let's move on to the next sum. 4 tan inverse 1 by 5 minus tan inverse 1 by 70 is this. We have to prove this formula. Okay, so see, 2 tan inverse x is tan inverse 2x by 1 minus x square. So we are writing this 4, we are writing as 2 into 2. So this becomes 2 tan inverse x. The formula is tan inverse 2x by 1 minus x square. So we are getting this as this. Now this again looks as 2 tan inverse x. So tan inverse 2x by 1 minus x square, we got it into this. And now from these two we are taking a minus common. So this is tan inverse a minus tan inverse b, which is this formula. Tan inverse a minus b by, so this is my a, this is my b. So tan inverse a minus b by 1 plus ab, we got this. Now please watch, this is again tan inverse a minus tan inverse b. So we are again using the formula tan inverse a minus b by 1 plus ab, and we are getting it as tan inverse 1, which is coming pi by 4, hence it is proved. Clear? So next, let's see the next sum. 2 tan inverse 1 by 5 plus sec inverse this plus 2 tan inverse 1 by 8 equal to pi by 4. Okay, so see, sec inverse 5 root 2 by 7. Let this be theta. So sec theta will be what? That means this is my hypotenuse, this is my base, as you can see. So my perpendicular is coming 1. So cos theta will be what? Base by the we want what? We want tan. So tan theta will be perpendicular by the base. So here we have written, instead of this we are writing this. Clear? So now from these two, please watch, we are taking a 2 common and using the formula tan inverse a plus tan inverse b equal to tan inverse a plus b by 1 minus ab. Solving it, we are getting it this, and it was sec inverse 5 by root 2, which is coming tan inverse 1 by 7. Now we are applying 2 tan inverse x formula. So what is 2 tan inverse x? Tan inverse so using this is our x, we are getting this plus tan inverse 1 by 7. Again we are using tan inverse a plus tan inverse b's formula. So tan inverse a plus b by 1 minus ab. Solving it, we are getting tan inverse 1, which is pi by 4, and that is proved. Okay, so friends, let's see the next sum. Cos inverse x equal to 2 sin inverse x. We have to prove this. So let x equal to cos theta. We are putting x equal to cos theta. We are putting x equal to cos theta. So here this x becomes 1 minus cos theta by 2, and 1 minus cos theta is 2 sin square theta by 2. 2 cuts. Root over sin square theta by 2 will be sin theta by 2. Sine inverse of sine, we have done that. Sine inverse of sin x is x. So from here it becomes theta by 2. 2 cuts. It is theta, and theta will be cos inverse x. So this has been proved as this. Now let us come to, we have taken x as cos theta. So 2 cos square theta by 1 plus cos theta is 2 cos square theta by 2. 2 cuts. This become cos theta by 2. Cos inverse cos theta by 2 is theta by 2. So 2 and 2 will cut theta, and theta is cos inverse x. Clear? So let's see the next sum. Y equal to cot inverse. If y, the value of y is given, prove that this is coming. So y equal to, now we know that, please understand, this is the formula, we already know that. Tan inverse x plus cot inverse x equal to how much? Pi by 2. So cot inverse x will be pi by 2 minus tan inverse x. So here we have used it. Now see, it becomes minus tan inverse root x minus tan inverse root x is minus 2 tan inverse root x. So 2 tan inverse x formula, we are using it, is cos inverse 1 minus x square by 1 plus x square, root cuts. 1 minus cos theta is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. 2 cuts. It becomes tan square x by 2. Now please watch here. This is y equal to pi by 2 minus cos inverse tan square x by 2. So cos inverse tan square x by 2 is pi by 2 minus y. So tan square x by 2 will be cos of this, and cos pi by 2 minus y is sin y, which is proved. Clear? That means we are always thinking about the formulas which we are trying to come from these. Now slowly we are moving on to some very good sums, so please keep a watch very nicely. Prove that cot inverse of this plus cot inverse of this plus cot inverse of this is pi, and it is written here that A is greater than B, B is greater than C, and all are positive numbers. Okay, so let's see here. Cot inverse x is actually tan inverse 1 by x. So here it becomes tan inverse. This is tan inverse, this is tan inverse. Now this is whose formula? Tan inverse A minus B. Tan inverse A minus tan inverse B is tan inverse A minus B by 1 plus AB. So instead of this I can write this. So here we have written, this is actually tan inverse A minus tan inverse B. This is actually tan inverse B minus tan inverse C. Please note one thing, here A is greater than B. So directly we can write this. Here B is greater than C, so we can directly write, but here C is less than A, so we have to write pi plus tan inverse C minus tan inverse A. Please keep a note here, A is greater than C, so this can be written as pi plus tan inverse A minus tan inverse C minus tan inverse A. So what ultimately remains is pi. Next, so let's see the next sum. What is there? If cos inverse x by a plus cos inverse y by b equal to alpha, prove this. Okay. We already know this formula. So cos inverse a plus cos inverse b, this formula. So we have applied here. This is our a, this is our b, and this is, we are applying the formula. Cos inverse a into b by root over 1 minus a square into root over 1 minus b square. So solving this, we are getting this, and this cos inverse goes on this side, becomes cos alpha. Taking the LCM AB gets multiplied with this. Now what we are doing is we are keeping the root separate and others separate and squaring both sides. So this will be a minus b whole square, and this will also be square. So a minus b whole square is a square plus b square minus 2ab, and this roots will cut off. Now opening all the brackets, we see that many here x square and y square will cut out. So this comes. Now please note here, this is a square b square, this is a square b square cos square alpha. So if I shift this to this side, okay, so see it has become this. Now taking a square b square, others, this will be shifted onto this, this will be shifted, these two will be shifted onto this side, and this will be shifted onto this side. So taking a square b square common, we get this 1 minus cos square alpha is sine square alpha. So we get this. Now dividing by a square b square. So if I divide this by a square b square, what will remain is this. If I divide this by a square b square, what will remain is this. If I divide this by a square b square, it will remain this. And if I divide this by a square b square, it will remain sine square alpha, which is proved. Now next, see the next sum, friends. If cos inverse x plus cos inverse y plus cos inverse z is pi, prove that we are getting this. Okay. So from here what we are doing, we are transferring this on this side. Now applying the formula, cos inverse a plus cos inverse b is cos inverse ab minus root over 1 minus a square into root over 1 minus b square. This is the formula. This is the formula. Okay. So now this cos inverse is being shifted to this side. So cos 180 minus theta is minus cos theta. Cos and cos inverse will cut, so it is minus z. Now bringing z on this side and shifting the root to the other side and squaring both sides. This will be a plus b whole square. And if I square this, the roots will go out. So simplifying it, we get the solution. Simplifying this, we will get the solution of this. So friends, let's move to the next sum. If sine inverse x plus sine inverse y plus sine inverse z is pi, this is given, we have to prove this. Okay. So that means we can think that sine inverse x as a, sine inverse b, sine inverse y as b, sine inverse z as c. So sine a will be x, sine b will be y, sine c will be z. Okay. So from this we are seeing that a plus b plus c is coming pi. We have taken sine inverse x as a, this as b, this as c. So a plus b plus c is pi. So x can be treated as sine A, y can be treated as sine B, z can be treated as sine C. Now please watch this conversion. Sine 2a plus sine 2b plus sine 2c. What is sine 2a plus 2b? Sine a plus sine b, the formula is what? Please note here. Sine a plus b, sine a plus sine b, our formula is 2 sine a plus b by 2 cos. So using this here, 2 sine this plus this by 2, so 2 will cut, into cos this minus this by 2, so 2 will cut, it becomes this. Now what is a plus b? A plus b is pi minus c, and sine 2c is 2 sine c cos c. Now sine 180 minus theta is sine theta, so it's sine c. Taking 2 sine c common, it becomes this. Now again it is cos a minus b plus cos c. So what is the formula of cos a plus cos b? Two cos this is the formula. So applying this, we are getting this and this. Now see, a plus c is actually pi minus c. A plus c is pi minus c. What is a plus c? A plus c will be pi minus b, sorry, pi minus b. So pi minus b is pi minus 2b. That means it is pi by 2 minus b. And from here if I take minus common, it becomes how much? So b plus c is what? Pi minus a. So this becomes how much? It is minus of pi by 2 minus a. So cos 90 minus theta is what? Sin theta. So it becomes sin b. And cos 90 minus a will become sin a. Okay. That means this formula can be written like this. So what is sin c? 4 sin c sin b sin a. Okay. Now from here, so this formula is actually coming like this. Now what is sin 2a? Sin 2a is 2 sin a cos a. Sin 2b is 2 sin b cos b. 2 sin c cos c. And this is this. So sin a. Now see, from here if I cut 2, 2, 2, 2, and this remains 2. So sin a, cos a is root over 1 minus sin square a. Cos b is root over 1 minus sin square b. Cos c is root over 1 minus sin square c. Now instead of sin a, sin b and sin c, please keep putting the x, y and z. And that is your answer. That is your answer. So please watch the sums very carefully, because these are not very easy sums. You have to solve them. You have to pause them, solve them along with me. Then only you will be able to understand it. Clear? Evaluate tan of this. So see, this is 2 tan inverse x. So whose formula is tan 2x by 1 minus x square. And pi by 4 I am writing as tan inverse 1. So it is coming tan inverse 5 by, so this is tan inverse a minus tan inverse b. The formula is tan inverse a minus b by 1 plus ab. We are using the formula tan inverse a minus tan inverse So we are solving this and we are getting this. So this is our answer. So next is evaluate tan of half cos inverse root 5 by 3. So let half cos inverse root 5 by 3 be theta. So cos inverse root 5 by 3 is 2 theta. So cos 2 theta is root 5 by 3. So we can understand that this is my base and this is my hypotenuse. So I get the perpendicular. So cos 2 theta again has a formula 1 minus tan square theta by 1 plus tan square theta. This is coming root 5 by 3. 1 minus tan square theta by 1 plus tan square theta. So from here we are finding tan square theta is coming this. So tan theta is coming this. Okay, that means what? This was taken as theta. That means this could have been written as tan theta. And tan theta we already got. So the value of this is this. Let's see the next sum, friends. Tan inverse of this equal to alpha. Prove that x square equal to sine alpha. Okay. So let x square equal to cos 2 theta. So this becomes root over 1 plus cos 2 theta, root over 1 minus cos 2 theta, root over 1 plus cos 2 theta, root over 1 minus cos 2 theta. And 1 plus cos 2 theta is 2 cos square theta. So 2 remains under root. Cos square theta comes out at cos theta. 1 minus sine 2 theta is 2 sine square theta. So it becomes this. So root 2 will be cut out. It becomes this. So now dividing by cos theta. Dividing, we have done what? Dividing by cos theta, up and down. So this will cut out as 1. This will become tan theta, this will become 1, this will become tan theta. Now this 1 we have taken as tan pi by 4 minus tan theta, and this here we have done 1 into, so that 1 is tan pi by 4, and this is the formula of tan A minus B. So tan inverse and tan will cut, it becomes pi by 4 minus theta, which was alpha. So theta was cos inverse x square. We have taken theta, we have taken x square as cos 2 theta, we have taken x square as cos 2 theta. So 2 theta will be cos inverse x square. So theta will be half cos inverse x square. So using that, instead of theta we are using half cos inverse x square. So pi by 4 minus alpha is this. Okay, so what we are doing is we are multiplying by 2. We are multiplying by 2 this equation. We are multiplying by 2. So we are getting pi by 2 minus 2 alpha equal to cos inverse x square. So cos of pi by 2 minus 2 alpha is x square. So x square equal to sine 2 alpha. Because cos 90 minus theta is sine theta. Let's see the next sum. Prove that tan inverse of this plus tan inverse of this is coming to b by a. So let us take this part as theta. So cos inverse a by b is 2 theta. So cos 2 theta is a by b. And we know cos 2 theta is 1 minus tan square theta by 1 plus tan square theta, which is a by b. So from here we are finding the tan theta. We are simplifying and finding the tan theta. So theta will be what? Tan inverse of this. Clear? That means this I have taken as theta, which is tan inverse. So I can write, so this first part, the first part becomes tan pi by 4 plus tan inverse of this plus tan pi by 4 minus tan inverse of this, because this is also taken as theta. So now please watch one thing, that is this formula look like tan A plus B. So that is why it is tan A plus tan B by 1 minus tan A into tan B. Please watch. Similarly, this looks like tan A minus B, which is tan A minus tan B, this is our B, by 1 plus tan A, and this is our tan B. So tan pi by 4 is 1, as you all know that. Wherever is tan pi by 4 we have put, and tan inverse will cut. Tan and tan inverse will cut everywhere. So it becomes this and this. So now simplifying it, see, this is basically simplification. We are getting this, and then the final answer is this. So from here, please note that we have done some simplifications. It is nothing just but normal simplifications which you will do, and you will get this answer and then this. Okay, so these are very normal simplifications. Let's see the next sum. Tan inverse this plus tan inverse this is equal to pi by 4. Solve for the x. Okay, so tan inverse x minus 1 equal to tan inverse this I can write as tan inverse 1. So tan inverse 1 minus this. So it is tan inverse A minus tan inverse B's formula. So we are using this formula. A minus B by 1 plus AB. Tan inverse A minus tan inverse B. So we are using tan inverse A minus B by 1 plus A into B. Okay, solving it we get this. Now tan inverse cuts from both sides. So it is this, and on solving we get this is the answer. Let's see the next sum, friends. So next sum says again solve. Tan inverse 2x plus tan inverse 3x is pi by 4. So again we have taken this as tan inverse 1, and this comes on this side. So tan inverse 1 minus tan inverse 3x. So tan inverse A minus tan inverse B is tan inverse A minus B by 1 plus tan A tan B. So using this, so then tan inverse and tan will cut this, and on solving we are getting minus 1 and 6, 1 by 6. Similarly this, so this is tan inverse A plus tan inverse B. So using the formula tan inverse A plus B by 1 minus AB. On solving this we are getting this. So tan inverse and tan cuts, we get this. We solve, x is coming 4 by 3 or minus 3 by 8. This is the answer. Let's see the next sum. Sine inverse 3x by 5 plus sine inverse 4x by 5 equal to this. So we're using this formula on this side. So this is my A, this is my B, this is my B, and this is my A. Solving it we are getting this. Now sine inverse and sine inverse will cut from both sides, and we are getting this. Now we are cutting the common x, and on solving we are getting x equal to plus minus 1 from both parts. Okay, plus minus 1 from both parts. So please, till here we got one thing, and then when we are seeing this, please watch one thing. When we are seeing this, then we can find out that the values are coming x equal to plus minus 1. Let's see. Sine inverse this minus sine inverse 2 sine inverse this is pi by 2. So let us take this on this side. We are getting this. So then sine inverse comes to this part. We are getting sine. Sine inverse changes the place, becomes sine. Sine 90 plus theta. Sine 90 plus theta. Sine pi by 2 plus theta is coming cos theta. So using this, 2 sine inverse x can be written as cos inverse 1 minus 2x square. So cos inverse and cos will cut. It becomes this. Solving it, we get either x is 0 or x is half. So we see that when we put x 0, this relation completely satisfied, but when we put x equal to half, the relation does not satisfy. That means x equal to 0 is our solution. Clear? So friends, with this we have completed the full inverse trigonometric functions, and I would request you, please go through each of the every sum, but before that I would suggest you, please go through the formulas, because these are the only things which can guide you for doing the sums in a proper way. So wherever I have discussed the formulas, please, these are the formulas, please go through the formulas very nicely, because these are the only things which can guide you properly to do the sums. Okay, so as you can see that this chapter is based completely about knowing how well you know the formulas. So my request is, please see the part 1. Please see the part 1 before you move to the part 2. That will help you. And when you move to the part 2, so this was part 2. Basically we are doing the part 2 of the inverse trigonometric functions. So we have completed the part 1 and part 2, and I hope you have understood. And if not, please go through it in a very you pause the video and then please keep doing along with me. But before that, please note down all the formulas so that it can help you. Okay, so with this we finish. We come to the end of this trigonometric functions, and I hope you have understood and enjoyed. So please subscribe the channel Parijat Sir Classes if you have liked it. Subscribe, like, share the channel. Okay, so it's again, thank you so much from my side, and thanks a lot.